Now let's take another question. It says that we have to find all the ordered pair xy such that it satisfy this equation and both the value of x and y has to be integer. I'll rate this question as a difficult compared to the kind of question which appear in CAT. But one should do the practice of this question because the approach for such question will help you to solve all the questions of a similar kind which have a lower difficulty level. So let's start with the solution. Now it says that 5y square plus 2xy minus 80 is equal to 0. So we have to find such values of x and y which has to be integer and satisfy this equation. So for simplicity I'm just I'm modifying the equation, so it will be, I can write it as 5 of y square plus 2xy is equal to 80. So this is the LHS part, this is the RHS part. Now I'll make certain kind of observation here. Now if you observe the second term, that is 2xy, it will always be even irrespective what the value of x and y we take. Obviously we have to take the integral values only, but 2x into y will always be even, and the RHS is an even number, so we are left with no other choice for the first term to be even only, that is this term will always be even. Since 5 is the coefficient of y square, so I can say that y has to be an even number, and this is very important deduction we have done, that y cannot be odd, it has to be even only. Further, we can see that the first term is a multiple of 5, the RHS is also multiple of 5, so second term has to be multiple of 5, which can be done by two ways, either keeping x as a multiple of 5 or y as a multiple of 5. So we have two cases here, either I can take x as a multiple of 5 or y as a multiple of 5, but y will always be even, that is sure, because otherwise if I take y as a multiple of 5 but an odd number, this expression will be an odd, so odd plus even will never give us an even number. So let us take these two cases one by one. So I am taking case 1 where y is not the multiple of 5, in fact x is the multiple of 5. So I am taking that y is not the multiple of 5 but x is multiple of 5, and y has to be even in both the cases. So let me assume that y is equal to 2p for some integral value of p and x is equal to 5q for some integral value of q. Let me substitute the value of y and x in the given expression or in this equation. So let me take it as equation 1. So it will be 5 into 2p square plus 2 into 5q into 2p is equal to 80. On further simplification, I'll be getting 20p square plus 20pq is equal to 80, or p square plus pq is equal to 4. And we have divided both sides by 20. Now this can be factorized as p into p plus q is equal to 4. Remember that the value of p and q, if they are integer, will be getting the corresponding value of x and y, because we have taken y as 2p and x is equal to 5q. So the number of pairs of pq will be the number of pair of x and y respectively. Now the only way that the 4 can be written as the product of two numbers are if I take p as 1 and p plus q as 4, or p as 2 and p plus q as also 2, p as 4 and p plus q as 1. I can take the negative values also. So first of all, let us make a small table here. So this is p, this is p plus q. So let me take it, this is the value of p, this is the value of p plus q, this is the value of q, will be getting correspondingly. So if p plus q is 4 and p is 1, then the value of q is 3. Similarly, if p is 2, p plus q is 2, so the value of q will be 0. Here it will be minus 3. And we can take the corresponding negative values also. For example, if p is -1, then p plus q should also be -4. If it is -2, then this is also -2. If this is 4, -4, then p plus q should also be equal to -4. And the corresponding value of q would be -3, 0, and 3. So if p is 1 and q is 3, the corresponding value of y would be, or y and x would be 2 and 15 respectively. Now for all these values of p and q, will be getting the corresponding values of x and y, and that will be the integral solution of the equation. I'm not going to test for all the values. Let me take some of the values, and then I'll leave the other values to be tested by the student. So I'm taking the first value. So for p is equal to 1 and q is equal to 3, the value of y would be 2 and the value of x would be 5 into 3, that is 15. So if you put x is equal to 15 and y is equal to 2 in the equation, in the LHS, it should be equal to 80. So it will be 5 into 2 square plus 2 into 15 into 2. So this is going to be 20 and this is going to be 60, which is equal to 80. Similarly, you can test for all the other values. So I can say that the number of pairs for x and y would be 6 if I have taken the case number 1. These are the 6 solutions for case number 1. Now let's take for the case number 2. So for case 2, I'll be taking y as multiple of 5. And for this, x could be any number. I don't have to put any constraint on x, because the moment y is a multiple of 5 and it should be even, I can say that the first part will be even and the second portion will also be even. In fact, both the part will be multiple of 10, so that the RHS is also multiple of 10. So let me assume that the y has to be even as well as multiple of 5. So let me assume that y is equal to 10 of p. 10 of p, and say x is equal to q, because we don't have any constant on x. Now again, substituting into the equation 1 here, we'll be getting 5 into 10p whole square plus 2 into q into 10p is equal to 80. On simplification, I'll be getting this as 500p square plus 20p cube, which is equal to 80. Now dividing it by 20 in both the sides, we'll be getting 25p square plus p cube is equal to 4. Again, I can take p as common, so it will be p 25p plus q is equal to 4. Again, we can have the same six different values of p and the corresponding 6 different value of the other factor, which is 25p plus q, and then we can get the value of the x and y respectively. So the solution for this also will be 6. Just for the clarification, I am writing the every values. If I take p here, the value of 25 plus q here, the corresponding value of q. So if I take p as 1 and 25 plus 20, this is 25p. So 25p plus q would be 4. And if I take this as 2, this will also be 2. This as 4, this will be equal to 1. If this is -1, this is -4. This is -2, this is also -2, and this is -4, and this will also be, oh, I'm very sorry, I think here it will be -1. So this will also be equal to -1. So the corresponding value of q would be -21, -48. It will be -99, 21, 48, and 99. So again, you will be getting 6 different pairs of x and y. So the total number of pairs is 6 plus 6, which is 12. So the answer for this question is 12 such pairs.